Density. Density measures how tightly stuff is packed into a given amount of space. So, for example, let's say that we have a classroom, and in that classroom we have one or two students. That classroom would not be very dense at all, it would have a very low density. But if we were to pack the classroom with many more students, then all of a sudden the classroom would have a very high density. So, again, density measures how tightly stuff is packed into a given amount of space. Now, when it comes to density math problems, there's two formulas that you're going to have to be familiar with. The first one is density equals mass divided by volume. The next one is population density equals population divided by area. The easiest way to remember both of them is to just remember that density measures how tightly stuff is packed into a given amount of space. Let's look at our first question. A container with a volume of 84.75 cubic meters is filled with oil. The oil has a density of 724 kilograms per cubic meter. What is the mass in kilograms of the oil? Okay, so to begin with, let's start with our formula for density. Density equals mass divided by volume. Okay, now let's see what information is given to us in the question. They tell us in the question that the volume is 84.75 cubic meters. And they also tell us that the density is 724 kilograms per cubic meter. So let's substitute both of those values into the formula. Now I've included the units, but don't, if that confuses you, don't focus on the units. Just make sure you focus on the numbers because those are the most important parts. Okay, so we're trying to solve for mass. So with the information they've given us, it's very easy to solve this equation. All we have to do is multiply both sides of the equation by 84.75. Okay, so on the right hand side, the 84.75 cancels out. On the left hand side, if we multiply 84.75 times 724, that'll give us our answer, which is that the mass of the oil is 61,359 kilograms. For our next question, it says a cylindrical weight, pictured below, has a density of 9.6 milligrams per cubic millimeter. Using pi equals 3.14, what is the mass of the cylinder rounded to the nearest hundredth of a milligram? Okay, so as you can see, they've given us a cylinder and we have the radius. The radius is 4 millimeters and the height is 12 millimeters. So let's start with our formula. Our formula is density equals mass divided by volume. Okay, now in the question, they tell us that the density is 9.6 milligrams. So let's substitute that value into our formula. So we're going to swap out density for 9.6. Now, we also need the volume, but they don't give us the volume in the question. However, we could figure out the volume from the picture of the cylinder. Now, you got to remember that for the volume of a cylinder, the formula for getting the volume is area of base times height. Remember that the capital B stands for area of base. And since the base of a cylinder is a circle, the formula for getting the area of a circle is pi times radius squared. So let's replace the capital B with pi radius squared. Now let's substitute into our formulas. Let's substitute into the formula the values that we know, which is that the radius is 4 and the height is 12. All right, so we substitute that into the formula. And remember that in the question it says that they want us to use 3.14 for pi. Okay, so now let's follow the order of operations and begin with the exponent. 4 to the second power is 16, and 16 times 12 and times 3.14 will give us a volume of 602.88 cubic millimeters. So now that we know that what the volume of the cylinder is, let's substitute that into the formula. And now we're almost done. We just need to get mass by itself. So let's multiply both sides of the equation by 602.88. And on the left-hand side, when we multiply 602.88 times 9.6, that's going to give us our answer. Remember that it says to round to the nearest hundredth. So when we round to the nearest hundredth, our answer is going to be the mass of the cylinder is approximately 5,787.65 milligrams. Moving on to question number 3. A biologist estimates that there are 80 deer living in a circular section of a forest with a radius of 10 miles. The deer density is expected to be the same throughout the entire forest. What is the expected number of deer in 400 square miles of the forest? Okay, so first of all, let's picture this forest. The question says that the forest is a circular section. It's a circular section of a forest with a radius of 10 miles. So let's picture that. We have a circle, and that circle has a radius of 10 miles. And in that circular section, there are 80 deer. All right, so let's bring out our formula. We're talking about a population of deer, so let's use the population density formula, which is that population density equals the population divided by the area. Okay, now, do we know the population? Yes, we do. The population of the deer is 80. It says it in the question. Do we know the area? They don't tell us the area, but we could figure it out based on the fact that it's a circle. The area is a circle and the radius is 10 miles. So we can figure out that area by knowing the area, how to calculate the area of a circle. The area of a circle can be found with the formula area equals pi times radius squared. Okay, so since the radius is 10, let's substitute that number into the formula. So we have 10 to the second power times pi. So let's multiply 10 to the second power. That's going to give us 100 pi. Okay, now let's hold off for a moment before we multiply times pi. Let's wait on that. Okay, so let's just leave our answer in terms of pi for a moment. So the area of the circular section of the forest is 100 pi. Let's substitute that into our formula. So replace the word area with 100 pi. Okay, so now to figure out the population density of this circular section of the forest, we're going to do 80 divided by 100 times pi. And that's going to give us approximately 0.2546. Okay, now that's not our answer because, again, the question, if you look at the question, it's saying what is the expected number of deer in 400 square miles of the forest? Now, in the question, it says that they expect the deer density to stay the same. That's really important. Okay, the deer density is expected to stay the same. Okay, so let's use the same formula. Population density equals population divided by area. And since the population of deer, or I'm sorry, let's go to the area first. The area in the bigger section of the forest that they want us to calculate how many deer will be there, the area is 400 square miles. So let's put 400 where the area goes. Okay, and since the population density is expected to stay the same, okay, let's get the population density that we have and substitute that value, 0.2546, for population density. All right, so that's where we're going to substitute that value. Okay, so now the only thing left to do is to solve for population. All right, so we're going to do that by multiplying both sides of the equation by 400. And on the left-hand side, when you multiply 400 times 0.2546, you're going to get the population, which is 101.84. Let's round that number to the nearest whole number, and that'll give us our answer, which is that the expected number of deer is approximately 102. Okay, moving on to our last question. It says Naomi has a garden that measures 8 feet by 8 feet. She has 24 tomato plants in it. She plans to expand her garden as shown below. If she wants the density of the plants to remain the same in the expanded garden, how many more plants should Naomi put in her garden? Okay, so as you can see on the left-hand side, she has a garden. It's 8 by 8 feet, 8 feet by 8 feet, and it has 6 rows of 4 tomato plants each for a total of 24 tomato plants in that section of the garden. She's gonna expand the garden, and the question is if the density stays the same, how many tomato plants will she put in the expanded part of the garden? So let's start with our formula. Population density equals population divided by area. In this question, we're talking about a population of tomato plants. Okay, so we know that there are 24 tomato plants in an area that's 8 feet by 8 feet, a rectangular area that measures 8 feet by 8 feet. So, as you should know by now, to get the area of a rectangle, you multiply the base times the height or the length times the width, however you want to think about it. But basically, you're going to multiply 8 times 8, and that gives us our area, which is 64. Now, the reason we're doing this is because we need to know what is the population density in that section so that we could match it in the bigger section. Okay, so when we divide 24 by 64, that gives us our population density, which is 0.375 tomato plants per square feet. Okay, now that we have that, let's look at the expanded section of the garden. Okay, we got to figure out the area of the expanded section of the garden. And the way we're going to do that is by dividing it into familiar shapes. Okay, with the lines that I've drawn on the garden, you could see that we've divided it into 2 rectangles and 1 triangle. Again, we have 2 new rectangles and 1 triangle. We've divided that area into smaller familiar shapes. You could have done it all together and treated it as a trapezoid, but to avoid having to go over additional formulas, let's leave it as rectangles and triangles. Okay, so now let's go over how to find the measurements needed for those new sides that we have there. Okay, so first of all, you could see up there that section that line measures 6 feet. Now, if you look towards the bottom, okay, on the bottom of the garden, that entire line measures 12 feet. Okay, so that means that this section on the right measures 6 feet, and the other section on the left also measures 6 feet. Okay, now let's look. Oh, and the section on the top right there is also 6 feet. Okay, now let's look all the way on the left. Okay, and we can see that this side of the garden is 8 feet. So if you go to the right, we have this entire line is 16 feet. So if the bottom half is 8 feet, that means the top half also has to be 8 feet. And that means that this line right there has to be 8 feet. Okay, so now that we have those new dimensions, those new sections figured out, okay, let's start calculating the area of those rectangles and triangles. Okay, so let's start with, well, first of all, remember that the area of a rectangle is calculated by multiplying the base times the height. You could also think about that as the length times the width. So let's start with this rectangle right here. The bottom side or the base is 6 feet and the height is 8 feet. So if we multiply 6 feet times 8 feet, we're going to get our area for that rectangle, which is 48 square feet. Now let's go to the rectangle on the right. The base is 6 feet and the height is 16 feet. So if we multiply 6 feet times 16 feet, we're going to get the area of that section, which is 96 square feet. And then let's finish off with the triangle. To get the area of a triangle, you have to get half of the base times the height. Okay, so if we look at the triangle, the base is 6 feet and the height is 8 feet. So we're going to multiply 6 times 8, which will give us 48, and then divide that number by 2. And that gives us the area of the triangle, which is 24 square feet. Now let's go ahead and add all 3 of those numbers in order to get the combined area of that new section of the garden. If we add all 3 numbers, that's going to give us an area of 168. I meant to put square feet. That was my mistake. So it's 168 square feet. Okay, so now that we have that, we have the area of the expanded garden. And let's go back to our formula. Population density equals population divided by area. The question is, what is going to be the population of tomato plants in that new area? Okay, do we know the area? Let's go back. Do we know the population density? Yes, it has to be the same as in the initial garden. So the population density has to be 0.375. So let's substitute that value in for the population density, 0.375. Okay, now do we know the area? Yes, the area is 168 square feet. I accidentally left out the exponent. Okay, so let's substitute that for area. Again, this is just the area of the expanded part of the garden, the new part of the garden. Okay, so the bottom number is going to be 168. Now all we have to do is solve that equation for population. Okay, so let's multiply both sides of the equation by 168. And on the left-hand side, when we multiply 168 by 0.375, that's going to give us our answer, which is 63 tomato plants. Okay, that's how many plants Naomi can plant, tomato plants, in order to maintain the same amount of density that she had at the beginning of the question in her initial garden. All right, guys, that's it for this part on density. Make sure to subscribe to my YouTube channel. I'm going to be uploading more videos to review for the FSA, the Geometry FSA.